Hello, my name is Pratik Mudlar. I'm gonna be explaining my part of my experiment, part of my assignment, and the assignment was all about looking for an application or web server, or identifying an application or a web server, and creating VPC with its appropriate servlet and respective sub-security groups, and there is a load balancer and then auto scaling group. Now this application web server will be routing traffic to the VPC or the virtual private cloud, and I have to begin with the started creating with the VPC. So we will jump directly to the configuration. Now these are the VPC that I created. I created one VPC by the name Pratik, which is this one, and if you go inside it will have a look at the configuration. VPC has 4 subnets and 2 availability zones, that is to submit each availability zone, one public and one private. And let's dive into the components of the VPC. We have the subnets. The subnets are here. These are 4 of them. This one, this one, this one, this one, and as you can see, they are all available. Yeah, that's pretty much everything about the subnets. So a route table, we can view that we can have route tables, and now starting with private subnet 1 in US East 1, we have a route. So this is the route, and when the route is, we have one that is pointing to the NAT gateway from the internet, which will enable us to communicate with the private resources in the private subletting this particular availability zone or this particular availability. And now we have the local route in the component. In the VPC, we will communicate with each other using these local routes. Subnet associations, we have these private subnets. We have only one subnet association where private US East 1 has been associated with this ID. So then we have we have the next route table. See what we have in the next route table. So in this case, we happen with the private to the subnet in the second availability zone, that is US East 1B. The same case is happening. We have a NAT gateway communicating in the internet with the communication. For communication with the internet, that is we are in the position to accept the private resources in that private subnet. So the same happened with the local communication, and hereby the target destination from our destination, which is our VPC. Okay, so now for the public routes, we have been attached to the one internet gateway, that is to enable us to communicate with the resources in that public subnet. Now, so the local routes, this is the route that we will access the public services, and this use subnets to the internet gateway. We have one which has been attached to this internet gateway, which has been attached to both of the public subnets. That's all about the subnets. And now my next resources that I have created was a load balancer. Okay, let's open it and yes, see here. So, and yes, here comes the load balancer. We have Pratik load balancer. Now this load balancer has an internet facing on the port 8 or port 80, HTTP port 80, and then let's look at this list as so. So our protocol is HTTP port 80, and we have one rule. We have a target group that is EC2 instance that will be created by outer scaling group, which cannot be increased to whatever amount that the customer desires, or via they load all the customer desires. So if you go to Pratik.target groups and see if we have an instance, now this instance load balancer will be in traffic, and you can see this is healthy, and this one instance is in US East 1B. Then this is an instance we have. This is an instance ID and the port 80, and the detection length is normal. Okay, so and on health checks we have chosen the elastic load application load balancer to do the healthy checks by the EC2 and the load balancer to do the health checks. That's pretty much what they have for the load balancer. Our second thing that I have created is an auto scaling group, and before creating that auto scaling group I had to create a launch template. So that's what we have now. It is my Pratik launch template, and let's open this, and this running on T2 micro instance. And then what I like us to do is to go to the advanced details, which will have to give us the code that used for the script that I used for my HTTP website. HTTP script that I used for now web server, and it will be echoing hello world from the particular IP addresses of the target instances. Will be demonstrating when I'll test the load balancer. So yeah, that is all about the launch template. It's like running on the T2 micro EMI T2 micro instances, and next to Amazon machine image, which is on the free tier. And now basically it's all about launch template, and yeah, all the rest are pretty much I didn't not include any templates, so now let me dive into auto scaling group. Now that's launch template on my auto scaling group. I have configured at least for desired capacity to be 1, minimum capacity to be 1, maximum capacity to be 4. I will be testing this, and I'll be increasing the capacity in a few to see their load and to see the configuration on how the load balancer will be routing traffic on instances, or how the instances will be increasing from the after the configurations. And now you can see the health check type is elastic load balancer in the EC2. When not exact, reaching pretty much this thing now. Okay, we have enabled the monitoring, so let's go to the monitoring, CloudWatch monitoring. And for the auto scaling, you have the EC2 as well, and all that is loading. Let's test our load balancer. Now what we do is get the DNS name and open it in a new tab. So it's a new tab, and then we will copy DNS, then we will enter it. It will give us the, as you can see, it is giving us the instance IP and then echoing the hello world statement. Now it's internal. I want us to do something. I want us to increase the number of instances in our auto scaling group, and now we see, okay, so before we go there, this is all metrics for auto scaling. Now these are basically our metrics for CloudWatch monitoring details. So what I would like us to do is to test it. I want us to increase the number of instances, that the desired capacity, and then we see what our load balancer will give us. So let's just do this one, and we will edit the capacity to the group size. Now we'll have this become how many you have. Let's make them 3. Then always minimum should be 3 and desired to be 3. And now we will update this. Okay, so let's refresh it. Auto scaling groups as it is updating, and it is updated, and now we'll go. It is updating. Let's review our dynamic scaling. How are the dynamic scaling policy? We'll just dynamic scaling policy, target tracking scaling, which is enabled, and by VPC my CPU utilization is to be 50, and they are enabled. This is the dynamic scaling that I use, that is target tracking policy for my case. So yeah, let's see if it has updated. Still updating, and we can refresh our load balancer and see if there are changes in hello world and the particular IP addresses. Instances, for the instances that will be created, and it is taking some time. It is created our every instances, and let's go back to the load balancer DNS, and now try refreshing. Notice the change in the IP addresses. Here we have 149.1, 149.1, and now we have, it will change. You can see it has changed to 131, 138. That is the second IP. It is for the second instance, and now it has changed to 157 and 138. Let's repeat that. You see that 149-1, and now the second one is 131-138 and 157.138. So we can adjust our load balancer is working properly. And yes, if we go to our Pratik security outer scaling group and then we go to the instances, you will see there has been an update on the running instances, and we are now 3. So you can see the running health checks are seen, but basically the instances are running, and that is all about testing for my load balancer. Yeah, so yeah, that's it.